Today we're going to start section 6.4, angle-angle postulate. Back in unit 3 when we were working with congruent triangles, we used side-side-side, side-angle-side, angle-side-angle, angle-angle-side, and HL to prove that triangles were congruent. Here we're going to use the angle-angle postulate to show that two triangles are similar. So if we take a look at our example here, right, the angle-angle postulate states that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So here we can see that angle K is congruent to angle Y, and angle J is congruent to angle X. So because we have two pairs of corresponding angles that are congruent, we can say that our triangles are similar. So for our similarity statement, we can say triangle JKL is similar to triangle XYZ. Just remember that order matters there, so we have to make sure that our corresponding angles match up. If we take a look at the first example, we want to determine if these two triangles are similar. So before we draw any conclusions, we want to make sure that we're finding any missing angles. So in triangle ABC, we want to find the measure of angle C. We know that all three angles in a triangle have to add up to 180. So to find the measure of angle C, we can do 26 plus 90, which is 116. And then we can do 180 minus 116, and we get 64 degrees. So we know that the measure of angle C is 64 degrees. And for the measure of angle X, we can do 64 plus 9, which is 154, and then we can do 180 minus 154, and we get 26 degrees. So after finding the missing angles, we can see that we do have two pairs of corresponding angles that are congruent. So we can say that our triangles are similar. Triangle ABC is similar to triangle XZY. Remember, order matters. So ABC, we go from 26 degrees to 64 to our right angle. So we have to follow that same pattern, XZY. Pause the video and try number 2 on your own. So here, looking at part A, right, we're given that angle D is congruent to angle AEB, right, both 54 degrees. Now we also know that angle A appears in both triangles, right? If I were to highlight both of my triangles here, I have a green angle A and an orange angle A. So in this case, angle A is overlapping in both triangles. So when we get to something like this where we have an angle that appears in both triangles, this is going to be the reflexive property. So we saw this a lot in sides, right, when we were doing congruent triangles. Here we're going to see that overlap in angles. So we can say that angle A, right, is congruent to itself because of the reflexive property. So because we now have two pairs of corresponding angles that are congruent, we can say that the triangles are congruent. So we can write our similarity statement. Triangle AEB is similar to triangle ADC. And for part B, right, our parallel lines here are going to help us find congruent pairs of angles. So one pair is here. These are alternate interior angles. So we can say angle R is congruent to angle T. Right? If we use our other transversal, we have angle S congruent to angle U. And those are both alternate interior angles. And then we also have vertical angles. Right? So angle SVR is congruent to angle TVU. And those are vertical angles. So again, we do have two pairs. In this case, we found all three of corresponding congruent angles. So we can say that our triangles are similar. Triangle SVR is similar to triangle UVT. Part C is a little tricky, right? By looking at the arcs on the angles, it doesn't look like we have any pairs of congruent angles here. But both of these triangles are equiangular triangles, which means that all three angles in both triangles measure 60 degrees, right? So in this case, because both triangles are equilateral, right, we do have two pairs of corresponding congruent angles, so we can say our triangles are similar. Triangle FGH is similar to triangle QRS. Last one, part D. Remember, whenever we have missing angle measures, we have to find those first before we can draw any conclusions. So I'm going to find the measure of angle FDC first. I'm going to do 32 plus 90, and I'm going to get 122. And then I'm going to do 180 minus 122, and I get 58 degrees. And then same thing for the measure of angle FDE. I'm going to do 58 plus 90, because I know that this is also a right angle here. And I'm going to get 148. And then if I do 180 minus 148, I get 32 degrees. So I know that this angle here is 32 degrees. So now looking at all of my angle measures, I can see that all three pairs of corresponding angles are congruent. So I can conclude that my triangles are similar. Triangle CFD is similar to triangle DFE. Remember, order matters, so we have to match up our corresponding congruent angles. In number 3, we do have two pairs of corresponding angles that are congruent. Angle A is congruent to angle F, and angle B is congruent to angle E. So we can say these triangles are similar by the AA postulate, angle-angle postulate. So here, triangle ABC is similar to triangle FED. For part B, we're just writing out our ratios for corresponding sides. So side AB corresponds with side FE. Side AC corresponds with side FD. And lastly, side BC corresponds with side ED. So here we're just replacing the side names with the numbers or the lengths of the sides. So we have 25 over 15, AC corresponds with FD, and then we have Y over 12, because Y and 12 are corresponding. For part D, we have 15 over 25, because 15 and 25 are corresponding, and then we have 18 over X, because 18 and X are corresponding. So now we want to use our proportion in part C to solve for Y. So for part E here, we have 25 over 15 equals Y over 12. I'm going to cross multiply, I get 15Y 300. And then if I divide by 15 on both sides, I get Y equals 20. And then for part F, to solve for X, I'm going to use the proportion in part D, 15 over 25 equals 18 over X. If I cross multiply, I get 15X equals 450. And if I divide both sides by 15, I get X equals 30. So now in order to find my scale factor from triangle ABC to triangle FED, I'm just going to pick a side from ABC. I'm going to go with 25. And I'm going to pick the corresponding side from triangle FED, which is 15. And then I'm just going to simplify this fraction. Divide both the numerator and denominator by 5. And I get 5 over 3 for my scale factor. All right, taking a look at number 4, I'm given that triangle LIH, so this yellow triangle here, is similar to triangle KJH. So this big triangle here that I'm highlighting in green. And we have to find A, B, and C. So here we know that triangle HIL is similar to triangle KJH, right? Because of the angle-angle postulate, right? First of all, these parallel lines give us these corresponding angles that are congruent. And secondly, right, the reflexive property tells us that angle H is congruent to itself. Because it appears in both triangles, it's congruent to itself. So the angle-angle postulate helps us prove that these triangles are similar. So for our similarity statement here, HIL is going to be similar to triangle HJK. Triangle HIL is similar to triangle HJK. Now to solve for x, we're going to have to set up a proportion. So to solve for x, we're going to set up a proportion using corresponding sides. So in the smaller triangle, we can use side HI, and that side corresponds with side HJ in the big green triangle. So we have 14 over 14 plus x, and then we have to pick another side. So I'm going to pick HL, which is 18, and HK, which is 18 plus 6, or 24. So now here I can cross multiply. I get 18x plus 252 equals 336. I'm going to subtract 252 on both sides. I get 18x equals 84. And then if I divide by 18 on both sides, I get x equals 4.6 repeating. And then to solve for y, I'm going to have to set up another proportion, right? So here I have y over 18. And then again equals 18 over 24. Here I cross multiply, 24y equals sorry about that, 24y equals 324. And if I divide both sides by 24, I get y equals 13.5. Other similarity postulates that can be used to prove that triangles are similar are the side-side-side postulate. So if three sides of one triangle are proportional to the corresponding sides of another triangle, then the two triangles are similar. So here we can see that the ratios of corresponding sides are proportional. They all reduce to 4/3, so we can say that these are similar. So triangle ABC is similar to triangle DFE. Remember, order matters, so we have to make sure we match up the proportional sides. We can also use side-angle-side postulate. So if two angles of two sides of one triangle are proportional to the corresponding sides of another triangle, and the included angle, so the angle in between the proportional sides, are congruent, then the two triangles are similar. So here we have the ratio of the corresponding sides, right? They both reduce to 3/2, so they are similar, and the included angle both measure 50 degrees. So the side-angle-side postulate works here. Triangle ABC is similar to triangle DFE. Order matters.